running a sketch test for the BYJ 5-volt stepper and axis 1 for my QUT drawing robot. I don't have the retainer on the bottom of this gear yet, so it's a little wobbly, but once I get the retainer set, you can see it's turning right well, and it's got some pretty good torque. I feel confident that these little steppers are going to work just fine. It's a unipolar stepper, so some people complain about repeatability. I don't think that's going to be a huge factor, given the fact that we're gearing it and we're translating that into a broader spectrum of motion. So you got to keep in mind we've got to hit a mark that's about that big. So I think if we miss half, if our stepper steps misses one step and we're on half a tooth there, we're not gonna miss a whole lot of range. You can get 5 of these steppers for $13 from Amazon Prime. The robot is pretty much done designing. I've started to put together an assembly manual. And that's coming together really well. I've got basically all the parts designed except for the retainer. Like I said, this gear is going to have this is my helper. This gear is going to have a plate here to hold it on the bearing. But this is really just a torque test for these steppers to make sure they're going to work. And the sketch is super simple to drive them. I downloaded this little stepper library, which is designed for this 5-volt BYJ-48 stepper. It's a 28 BYJ-48 5-volt unipolar stepper, and it's real simple. You set the speed. 200 is max, and this is pretty much our max speed. But I really think that's certainly fast enough. You got to think at 300 centimeters from the axis point, our arm's going to have a pretty decent movement. So I think that's plenty. And then you just set the speed. Like I said, I have it on max, and then you set it with how many steps to take. Then you tell the small stepper to steps to take, and then a delay before it goes back in the other direction. And then to make it go the other way, you just simply put a negative there. So I think this is real easily instigatable code to drive our robot. I'm probably going to get in and file that gear a little bit to clean it up, but all in all, this turned out pretty good. I still got to put the feet on here. I got the bolts just sticking through where the feet are going to go, but she's totally designed. I'm pretty sure that's all the parts except for this retainer plate to go on the bottom of this. I shrunk this hole just a little bit to make a little tighter tolerance for the bearing. You may have to play with that depending on how well your printer prints inside diameters. It turns out mine's doing pretty well, better than I expected. So I tightened the tolerance on that hole so I could get it properly centered. And then there's going to be a plate that goes across the bottom to catch the underside of that bearing, and that should hold this pretty well horizontal. and yeah, so it's doing pretty well. There's some adjustment. I made some adjustment slots in the motor mounting plate so that you could move the motor in and out to figure out how much bite you want on your tooth, and it's pretty much all the way forward. I may adjust that back just a little bit, but this print didn't come out super great. There's a few sections. It's kind of bowed. It warped just a little bit as I was printing it, and then I've only got about half tooth in certain places, so I may end up reprinting this altogether. I think it's probably usable, but I think a reprint's in order for that. I'm happy with the rest of this, and maybe when I get my Prusa and I got a heated bed, I can do away with some of that lifting and warping of the parts. But I've got all the STL files pretty much ready to load, and I'm gonna get it all assembled and test it first, and then I'll let you guys know. But so far, BYJ, it's a winner. Super easy. It comes with a little driver board. It's 5 volt. I'm running this powered from the Arduino actually, so I think we're good.